In this screencast, I'll show you how to use the combined gas law. It actually combines all our gas variables, pressure, volume, N for number of moles, and temperature all into one equation. And actually, all of the other gas laws can be found by analyzing the combined gas law. Now, oftentimes when we use this gas law, the number of moles are staying the same. Imagine that we've filled a balloon with helium and tied the balloon. The number of moles inside the balloon then is constant. We tied it and closed it. And so the beginning number of moles is going to be the same as the ending number of moles. N1 equals N2. And so if the number of moles is going to stay constant, like in that tied helium balloon, we can assume those are constant and going to be equal and cancel out on both sides of the equation. And then we might be changing the pressure and the temperature of the balloon, which could result in a change in its volume. And so three variables could change all at once. And this is actually the gas law that's found on the back of your periodic table. On the back of your periodic table, you'll find the combined gas law. P1 times V1 over T1 equals P2 times V2 over T2. So that's one version of the combined gas law and the one that we're going to be using the most in this class. Now, we could imagine that not only the moles are staying constant and we aren't adding or removing gas, but we might imagine that we're keeping the temperature. Maybe the temperature of the room is controlled and it stays constant. And if the temperature and the number of moles are constant, we cover up N and T in the bottom of the equation. And then look, the result is just that we have Boyle's law, that we have P1 times V1 equals P2 times V2. If the number of moles are constant, imagine tying that balloon if the temperature is kept constant in a room. Then let's imagine that we have a problem where pressure stays constant and temperature stays constant. You're controlling the pressure and temperature of your experiment, but maybe you're changing the number of moles and therefore the volume is changing. And then we go, okay, well, now what gas law is this? Well, this is just Avogadro's law. So all of the other gas laws are hidden inside this combined gas law. Let's say pressure stays the same. P1 is equal to P2. Let's say, again, that we're not adding or removing any gas from our container. But what we're doing is changing temperature and volume is changing. Well, then we have Charles' law. So all of the other gas laws come from the combined gas law.